And I'm back. Okay, so crisis averted. Actually, there wasn't really a crisis, it just was somebody who had a question. So, okay, now we have discussed writing equations of circles. We are going to get into graphing circles. And graphing circles, if you remember from what I talked about before, involves plotting the center and then plotting points kind of floating around the center that are the distance that the radius tells you. So we're going to plot the center first, and then it says use the radius as units north, south, east, and west. All that means is that from the center, you're going to go up, down, right, and left from the center point. So the center point is a guide, and then we are going to make 4 floaty points around the outside of the center, up, down, right, and left. Now, if the equation is already in standard form, like this first one, then we're in really good shape. If the equation is not in standard form, we have to put it in standard form. And there is a methodology to it involving completing the square, which I will go over with you in another example. So we're going to start by just actually looking at creating a graph. Now, if you remember what I said whenever you're graphing, you're going to pull out the center first. And when you pull out the center, use the opposite signs on these two values. So we're not going to use -2, we'll use +2. And we're not going to use +4, we use -4. So there's your center. And then to find the radius, because of the nature of the formula, whatever this value is over here, we are going to take the square root. And we get 3. So we have our center, we have our radius. We are going to plot and connect. We start by plotting the center to use as a guide. So I'm going to go 2, down 4, and there's my center point right there. And now I'm going to count 4 different points, straight up, straight down, right and left from the center, and I'm going 3 units because that's what the radius tells me. So I go up 1, 2, 3 points, and there's 1. Back to the center, down 1, 2, 3 points, and there's 1. Back to the center, right 1, 2, 3 points, 3 points, and there's 1. Back to the center, 1, 2, 3 points. So you can see these 4 points are equidistant from the center. And when I connect them, and it's going to be rough on here for me. Okay, it's going to be rough. Me trying to connect these to make it look nice. Like a circle. There we go. That's not terrible. I'm actually kind of impressed with what this looks like. It could look way worse. But we are connecting them to make a nice circular shape around the outside of the center. And all of these points that are on this circular shape are the same distance away from that center. 3 units. So if you have the information, it's not bad at all. It's when you have to find the information that becomes a problem. So I'm going to go to example 3, which is the most involved. And you can see that in example 3, we have this expression here, equation here, where it is definitely not in the standard form. So what we're going to have to do is complete the square. Now, there's a lot of stuff going on here, more than what originally went on in our completing the square steps. So my advice is to first rearrange this thing so that it's in the correct order. And the order that it should be in is x squared, then x, y squared, then y, and on the other side, it should have the constant. So I'm just going to kind of reorder this stuff over here because the constant is already over there. So we're looking at 4x squared. Then I'm going to put the minus 24x. Then for y squared. And then the 24y equals 28. All right, so now it's in the right form. And we can start our completing the square. Now, when you are completing the square, you are not allowed to have a leading coefficient. So if you have a leading coefficient in front of these terms, you have to get rid of it. And lucky for us, it does divide nice. But remember, if it did not divide nice out, you would still have to divide it out and deal with it in that hideous form. So we're looking at x squared minus 6x plus y squared plus 6y equals, on the other side, 28 divided by 4 is 7. Now, according to standard form, we should have parentheses that contain our x stuff and parentheses that contain our y stuff. So I'm going to go ahead and separate the x's and y's over here with parentheses. And when I do that, I'm going to leave myself a space in both of them that I will take up in a moment whenever I do my completing the square. I'm also going to put 2 spaces on the other side because remember, whatever we add to one side, we have to add to the other side as well. So when I complete my square, I'm going to be putting some extra numbers in here. The steps for completing the square say, once we have divided out the coefficient, we take half of b and then square it. So half of -6 is -3. And when I square -3, I get 9. That's the first value that gets added in. Then I'm going to do it again in my second parenthesis. Half of b and square it. Another 9. That doesn't happen all the time. It just happens here, and that's fine. Sometimes it's different values. Sometimes it's the same value. Regardless, it's going to be the appropriate value to create a perfect square trinomial in both of these cases. The goal of completing the square is creating a perfect square trinomial so that this thing can be factored into a single parenthesis squared, which is what we want anyway because that's what standard form looks like. It's a parenthesis squared. So we're going to have both of our parentheses squared here. The first parenthesis factors into x minus b squared. The second parenthesis factors into y plus 3 squared. Now, if you're at a total loss for where those came from, it comes from whatever you get when you take half of b. -3 in here, +3 in here. Now, on the other side, you just have some numbers, so go ahead and combine those numbers. 7 plus 9 plus 9. 7 plus 9 plus 9. Oh my god, I don't know why I can't do this in my head. 25. Goodness. I definitely should have been able to add that in my head. I apologize. But anyway, take a look at what we have here now, because now this looks an awful lot like standard form. And once it's in this standard form, we can go ahead and pull out the center and the radius. Now remember, for the center, you use opposite signs. So the opposite of -3 is 3. Opposite of 3 is -3. And for the radius, we take the square root. Square root of 25 is 5. Lucky for us, we got a nice integer radius again, and that's great. Remember, if not, you're going to have to figure out what the approximation is to use it in the graph. Now, once I have these 2 key pieces of information, that's all I need to draw my picture. So I plot the center, +3, -3, right here. And then I go from the center up, down, right, and left. So I'm going to go, let me get purple. I'm going to go up 5. 1, 2, 3, 4, 5 units. Back to center, down 1, 2, 3, 4, 5. Back to the center, 1, 2, 3, 4, 5. 5, back to the center, 1, 2, 3, 4, 5. And I was hoping I was going to make it without that happening, but it's fine. So there are my 4 floaty points that I'm going to connect as nicely as I can to try to make myself a circle. Oh, that wasn't too bad. And so there's my nice neat circle, all the points equidistant from the radius. Oops. And there's your graph. Oh, how'd that happen? There's your graph. Oh, that's okay, because that one looks even better. All right, so we have seen distance and midpoint formulas. We have applied them to specific pieces of circles, and then we have used them to write equations and graph equations. So you have seen everything that has to do with circle stuff. Now, the next time, the next lecture video discusses back to linear stuff, but it jumps all the way into chapter 10, and it's going to be a discussion of solving systems of equations, and we're going to solve them by graphing. We will solve them by the 2 algebraic methods, which are substitution and elimination. We will talk very briefly about systems containing 3 variables, and then a little bit about some application problems involving these systems. And then that is the last section in this unit. So should probably get that done tomorrow, maybe Wednesday, but in the next couple days, so that it's all set to go. And then, like I said, that'll cover everything from unit 3. All right, so if you have any questions or need anything, feel free to email me. And if you're in my in-seat class and you're watching this, I'll see you guys on Wednesday.